Welcome to SQL Queries. In this lesson, we're going to focus on SQL statements. We'll talk a little bit about advanced queries, and then we'll look at how the SQL tool can help us write advanced queries. Then we'll talk about how you can test the queries you create and how you can actually do non-select queries, such as update. Retrieving data from the database can be fairly complex, because we may need multiple sources of data that we can manipulate in different ways. By now, you should be familiar with aggregates. Although aggregates provide an easy visual way to fetch data from the database, sometimes you need more complex queries with which aggregates aren't able to cope. Besides using aggregates to query entities, it is also possible to write SQL statements that are fairly complex, for instance, containing subqueries, using the SQL tool. The SQL tool is available in server-side flows, such as server actions and screen data actions. The inputs and outputs have to be defined ahead of time, which you can do using the visual editor at the top. Inside the SQL tool is where you will be able to write SQL statements. You will write the SQL itself manually in the tab at the bottom. As you're writing it, the SQL tool will do syntax checking and tell you if the SQL you're writing has any errors. It will also highlight all of the different keywords, any of the different attributes or the entities, and the input parameters. It is important to know that the SQL tool is like a black box. This means that it doesn't have direct access to the outside scope. So to have access to data coming from the outer scope, we need to define the input parameters and their data types. The input parameters can then be used in the SQL query directly using the @ notation. Since you are manually writing the SQL, you have to know which database you're targeting, because each database implements a slightly different SQL dialect. If you're using SQL Server and you want to limit the number of rows retrieved, you would use top instead of potentially using something like limit as in other databases. When we're actually working with the entities and the attributes inside of the SQL tool, we have to kind of abstract the names for the entities and the attributes. Entities' names need to be surrounded by curly brackets. Attributes' names need to be surrounded by square brackets. That's because when we create an entity and its attributes, those become tables and columns. The tables and columns don't necessarily have the exact name of the entity and the attributes defined in Service Studio. OutSystems takes care of creating that for you under the covers. So the special syntax with the curly and square brackets is automatically translated by OutSystems to the physical names in the database. Before we move on to the SQL tool outputs, let's talk about structures. Structures are somewhat similar to entities in the sense that they are compound data types. However, they are simply a data type definition. They don't hold any value. Another important feature is that a structure is not a variable, but a variable can have its data type set to a structure. Since a structure is a compound data type, it is composed of multiple attributes. Each attribute has a data type, such as integer, text, entity, or even another structure. Let's go back to the SQL tool and its outputs. Besides defining the input parameters in the SQL query, it is also required to set the output entities and structures. It is mandatory to set at least one output structure or entity. These output entities and structures must map to the query output, that is, the select part. If we are doing a query with a set of columns in a select clause, then the output has to have the same number of columns and the data types must also match. Then, the output from the SQL tool is going to be just like in aggregates. The output will contain a list and a count. The list itself will have the usual attributes, and the current will have the output entities and structures defined in the SQL tool. Like in aggregates, the SQL tool also allows you to test queries. Inside of the Test Inputs tab, we can define the values for the input parameters, in case we have any. These values will be used to execute the query during the test. Clicking on the Test button will actually take us to the Test Output tab. In the Test Output tab, you'll be able to see the results of the query. Testing the SQL query is important to make sure that it works as expected. Last, but also quite important, is that we can use the SQL tool to do non-select statements. When we do selects, we're really just making a query from a set of tables. But the SQL tool allows us to do non-select statements, which includes things like inserting records, updating records, and deleting certain records. Each entity already provides some of these capabilities via the entity actions. However, for more complex use cases, using a delete statement to delete records in bulk may actually be easier and more performant. SQL statements that are deletes, inserts, and updates are written normally as well, with the special curly and square brackets syntax around entities and attributes. These SQL statements don't have a real output, but we still have to define an output entity or structure. Here, a dummy one will do, or preferably, you can use the entities upon which you are acting.